We are going to do multiplying and divide rational expressions. So in problem number 1, it says simplify and state any restrictions. So I have x squared plus 7x plus 10 divided by x squared minus 3x minus 10. I noticed right away that I could factor these trinomials. So I'm looking for two factors that multiply to 10 and add to 7. That's 5 and 2. So I'm going to check. My first term, x times x, x squared. My last term, 5 times 2 is 7. And then because my coefficient is 1, if I just go 5 plus 7, 5 plus 2 is 7, then I know that's correct. But then my denominator, I'm going to factor this. Two factors multiply to 10. Negative 10 add to negative 3. It's going to be negative 5 and positive 2, so I'm going to check. I'm going to check my middle. Negative 5x plus 2x is negative 3x, so that's correct. So I want to simplify this, so I'm going to reduce it. And then I notice that x plus 2 and x plus 2 reduce. So I get x plus 5 over x minus 5. Now it says the restrictions. The restrictions are it cannot equal 0 because then it's undefined. So for my first one, x can't equal 5. And my second one, x cannot equal negative 2 because those would be zeros. So on my graph, because this does not reduce, it causes an asymptote on the graph. But this one does reduce, so that would cause a hole in the graph. So in this problem that you're trying, you need to factor first. 12 and 4 comes out of both of those. So I have 4 times x minus 3. And then x squared minus 9 has no middle term, so it's a conjugate. So square root of 9 is 3. So I get plus 3 minus 3. So I'm going to find my zeros right now. So this cannot equal negative 3, because that would be a 0. This can't equal positive 3. So I almost could reduce here if these two are switched around. So what I'm going to do, I am going to take out a negative 4. I'm going to take out a negative 1 instead. So if I take out negative 1, I could flip these around. Take out negative 1, that's how I get negative 4. Then I get x minus 3 instead of 3 minus x. And then these two reduce. Since I'm reducing, this one causes a hole in the graph. This one would be an asymptote. So I end up with negative 4 over x plus 3. In problem number 2, we're going to multiply these two rational expressions. And I notice right away, x squared plus x minus 6, I can factor that. So I'm going to factor that to x plus 3, x minus 2. And then x squared minus 25, that's a conjugate. So I get x plus 5, x minus 5. And then what multiplies to 3 and adds to 4? X plus 1, x minus 1. So now I'm going to reduce. And the rule for reducing is I could reduce a numerator with a denominator. So I have x plus 3 reduces with x plus 3. And then I have x minus 5 reduces with x minus 5. So I end up with x minus 2 times x plus 5 over x minus 1. So my restrictions, I cannot have 5 here because that's undefined. I cannot have negative 3 and I cannot have negative 1. In problem number 3, we're going to divide rational expressions. So I have 2 minus x over x squared plus 2x plus 1 divided by x squared plus 3x minus 10 over x squared minus 1. So when I divide, I am going to change it to multiplying the reciprocal. So I am going to keep my first rational expression the same, except I notice that I have what multiplies to 1 adds to 2. It's x plus 1 and x plus 1. So I am going to flip this upside down. So on top goes x squared minus 1, and that's made up of a conjugate x plus 1, x minus 1. In my denominator, what multiplies to negative 10 adds to positive 3. That's positive 5 and negative 2. So I can start reducing problems, except I notice that this is backwards. To get it switched around, if I take negative 1 out. So I took negative 1 out. Now I have x minus 2. And that will help me reduce. So I am going to look for where I could reduce it. So I notice right away that x minus 2 and x minus 2 reduce. And that's got to be, the rule is it's a numerator and it's a denominator. So I'm going to go x plus 1, reduce it with x plus 1, and then nothing else reduces. So in my numerator, I have that negative 1. You could just write negative or negative 1 times x minus 1 over x plus 1, x plus 5. And then my restrictions can't equal negative 1, can't equal negative 5, can't equal 2.